Okay, so this lesson is going to be about adding, subtracting, multiplying, and dividing two-digit numbers for the most part, but with decimals. So that's going to be the key here is that we're adding and subtracting, multiplying, dividing with decimals. We'll start off with adding. So to add decimals, the way I like to start it off is I write them on top of each other like this. So we have 9.3 plus 8.5, and then we put a big equal sign underneath like that. And then for adding, it's pretty straightforward. You're just going to add the columns like this. So if I look at the 3 plus 5 is 8. And for adding, I put the decimal point in the same spot. So the decimals is right there in that column. And then I move on to the next column, the 10 or the ones column right here. And I add those together. So 9 plus 8 is 17. My answer is 17.8. So adding is pretty straightforward. You're just adding columns. Keep the decimal in the same column so that it stays in a row. I'll show you again. This one's going to be a little bit trickier. Again, I start off by writing out the equation. So I have 8.8 plus 4.9 equals. I'm going to do the column. So I'm going to start with the right side. I'm going to go 8 plus 9. This one's a little trickier. So in the first example, we had 5 plus 8 over here, or 5 plus 3 equals 8, which was nice. The problem with this one over here, 8 plus 9 equals 17. So when you get a number that is greater than 9, so a two-digit number when you add them together, you're going to put the 7 here, and you're going to carry the 1 into the next column. So that is my 17. It's just I've had to break it up into chunks, like my 1's over here, my 7's over here for 17. Awesome. I then look at my decimal spot, and I keep it in the same area. The decimal stays in a nice row. And then I look at my ones column, so the next column to the left, but this time there's 3 things in the column instead of 2. So I'm going to add all 3 things. So 1 plus 8 plus 4 is 13. My answer is 13.7. Awesome. You can try the last one on your own. I'm going to go a little faster. So if you want to pause the video, try it, and then see if you get the right answer or not. We have 6.4 plus 8.7. 4 plus 7 is going to be 11. The 1 carries up top. The decimal stays in the same spot. 1 plus 6 is 7. 7 plus 8 is 15. My answer is 15.1. Awesome. That's addition. Let's try subtraction. So if you look at lesson or question D, I'm going to set up subtraction the same way that I set up addition. So I'm going to go 8.5 minus 6.3, like that. And then a big line underneath means equals. And just like addition, I'm going to do this column by column. So I'm going to start on the right column. And you go 5 and 3. So instead of 5 plus 3, this time it's 5 minus 3. 5 minus 3 is 2. The decimal, again, I notice that it's right here, so I need to keep it in that spot. The numbers in the ones column, I have 8 minus 6 is 2. So my answer of 8.5 minus 6.3 is 2.2. Perfect. With E, we're going to do the same thing. So we're going to set it 1 on top of each other. So I've got 7.2 minus 4.5 equals. And again, we're going to focus column by column. You're going to notice that this one's a little trickier. So when I go to subtract 2 and 5, it actually doesn't work. Right? We know that 2 minus 5 is a negative number. We're not going to do negatives yet because we haven't gone all the way to the left digit. So we need to figure out a way in which we can make this subtraction actually possible. The way that we do this is we are going to go to the next column on the right. And I'm going to focus in on this number right here, the 7. And what I'm going to do is I'm going to subtract 1 off of that 7. I'm going to make it a 6. And what we did was we took 1 away so that we could put a 1 in front of this 2 to make it 12. And now I'm doing 12 minus 5 in the right-hand column. 12 minus 5 is doable. It's 7. I then realized my decimal stays in the same spot. And in the left column, instead of 7 minus 4, because I took 1 away, it's now 6 minus 4. 6 minus 4 is 2. So my answer to 7.2 minus 4.5 is 2.7. You've probably heard people refer to this trick of taking that 7 and turning it into a 6. They say we borrowed it. Right? You borrowed 10 is what people usually refer to. It's the same kind of idea. So if you had a teacher in the past who showed you something similar to this for subtraction, use what they showed you. And it's probably the same thing, just maybe different wording. For F, we'll try it again. If you want to pause the video right now, that'd be a good time to pause it and try F on your own. See if you can figure it out. I will talk myself through it pretty quickly, so you might want to just pause and try first and then follow and see if you did it right. Okay, I set up the question, so I have 9.7 minus 5.9. Again, I'm going to do the right column first. 7 minus 9 doesn't work. So what I need to do is I need to take 1 away from 9 to make it 8, and this becomes a 17 minus 9. 17 minus 9 is 8. The decimal stays in the same spot. 8 minus 5 is 3. My answer is 3.8. Awesome. Multiply. Multiplying is hard. So I'll show you my strategy, my favorite strategy for doing multiplication. Some people might call it doing long multiplication. So if you've heard that term before, that works. I'll show you just my strategy. There are other strategies out there. So if you have a tutor or a parent or another teacher who's shown you something else, feel free to do what they've showed you. As long as you get consistently good at it, your method doesn't actually matter. I'm just showing you the method that I like most. So when I set up my multiplication, again, I do it in this fashion. So I got 4.2 times 5.3 with a big equal sign underneath. And then I'm going to do the same thing I did before. I probably wrote that too big. I'm going to need a little bit more space. I'm going to focus on the right column first. So 4.2 times 5.3. I just need more space, so I'm writing it out a little bit smaller. I'm going to focus on the right column. I'm going to start with this number 3. And I'm going to work with that number 3 all the way through 4.2. So I'm going to ask myself, 3 times 2 is 6. And then I'm going to say 3 times 4 is 12. So that represents me taking that 3 and multiplying it by 4.2. I then am going to do the same thing with the number 5. Because the number 5 is not the furthest right number, we see that it's 1 away from being the furthest right number. I have to put a 0 right here. I'm going to do it in a different color so it kind of sticks out. I have to put a 0 here to start off my 5 timesing it. The reason why is because it's not in the furthest right spot, so I had to have a 0 right here to represent that furthest right spot. And then I can start by multiplying 5 and 2. So 5 times 2 is 10. When I do 5 times 2 is 10, I'm going to put the 0 here. So the 0 is representing the 0 from 10, but I don't actually put 10 in here. So I'm not going to put that 1 there. Instead, what I'm going to do is I'm going to put that 1 up here, kind of like addition, right? I have to put that extra number up top. And then I'm going to focus on 5 times 4. 5 times 4 is 20, and then I'm going to add 1. because of that 1 from before. So it becomes 21, like that. Awesome. I'm just going to put that 1 a little bit more over, like that. Awesome. So I've now done all my multiplication, and I came out with these two different numbers. You'll notice that I've kept things organized, like in columns. So when you're doing your math, especially with the multiplication, make sure that you're keeping things in line with each other. What we're going to do now is we've got these two different answers. We're going to add these two numbers together. When we add these two numbers together, we're going to do the same stuff we did in the first three questions. So 6 plus 0 is 6. 2 plus 0 is 2. 1 plus 1 is 2. And then there's an invisible 0 here. So 0 plus 2 is 2. And you get this answer of 2226. The last step is to figure out where the decimal goes. Okay, so the decimal, the way we figure out where that goes is by looking up at the question and asking ourselves, how many numbers were there to the right of the decimal? So if I'm looking, I should notice that there's one number to the right of the decimal. There's a second number to the right of the decimal. So for two numbers to the right of the decimal means my answer in multiplication should also have two numbers to the right of the decimal. So the decimal should go right there, giving me a final answer of 22.26. Now, I understand multiplication is a lot harder and trickier than addition or subtraction, so we're going to do a couple more, and I'll go slow for each one of them so you can kind of try to follow along. If you feel like you understand it, pause and move on to the next question and see if you can get it right without me. All right, let's look at H. We're going to try to multiply 6.4 times 3.5. For multiplication, we start with the first number right here, 5, and we're going to multiply it to everything in the number above. So I'm going to go 5 times 4 is 20. I only write the last number, so that's the 0 from 20, and the 2 comes up here. I then do 5 times 6. 5 times 6 is 30, and then I add that 2 that I put up there, so it's 32. Beautiful. I'm going to do the same thing now. I'm going to take this 3, and I'm going to start multiplying it into the 6.4 above. However, because the 3 is one spot away from being the last number, I need to put a 0 right there to show that it's one spot away. And then I can start multiplying the 3 by things. So I'm going to do 3 times 4. 3 times 4 is 12. The 2 goes here. The 1 goes up here. I then do 3 times 6. So 6, 12, 18. And then plus 1 is 19. And you'll notice that I've got these two different numbers. I have 320. I have 1,920. I need to add those things together. I do that by using the strategies I used in the first question. 0 plus 0 is 0. 2 plus 2 is 4. 3 plus 9 is 12. So I put a 2 and carry the 1. 1 plus 1 is 2. So I have 2,240, which is not my final answer because I don't have a decimal yet. So I need to ask myself, like, where does this decimal go? The decimal goes as many spots over as we started with spots to the right of the decimal. I was worded very poorly. I apologize for that. But the way we figure out where the decimal goes is by looking at the question and saying to ourselves, okay, there's two numbers to the right of the decimal. There's a 4 to the right of the decimal and a 5 to the right of the decimal. So my answer should have two numbers to the right of the decimal. So I should put a decimal right there. My answer is 22.40. Realistically, we don't need to write the 40. We could just say 22.4. But those are both the same thing. Those are equivalent numbers. Awesome. Let's try I. To multiply I together, first I'm going to rewrite it. So I have 7.6 times 5.8. I'm going to start with my first number in the second number there, so the 5.8. I'm going to do the 8 from the 5.8, and I'm going to multiply that to the numbers above. So I'm going to do 8 times 6. 8 times 6 is 48. The 8 goes here, but the 4 goes up here to be added later. I then do 8 times 7. 8 times 7 is 56, but then I add 4 to become 60. Awesome. I then start multiplying the 5. Because the 5 is 1 away from being the furthest right number, I have to put a 0 to show that it's 1 away. I then do 5 times 6. 5 times 6 is 30. So the 0 from the 30 goes here. The 3 from the 30 goes there to be added later on. I then go 5 times 7. 5 times 7 is 35. Then I add 3 to be 38. My goal now is to add these two results together. 8 plus 0 is 8. 0 plus 0 is 0. 6 plus 8 is 14. So the 4 goes there and the 1 goes there. And then 1 plus 3 is 4. Perfect. My last thing I need to do is figure out where my decimal goes. So the decimal goes to the right, or it goes 2 numbers over. I erased my 8 there. So because there's 1 number to the right of a decimal, 2 numbers to the right of the decimal, my decimal and my answer should have 2 numbers to the right of it. So the decimal goes there for an answer of 44.08. Awesome. Remember that you will have non-calculator questions, so you will have to be able to do this stuff without a calculator. So this is going to be mental math. All right, the last 3. So we are going to now move on to division. Again, people have different strategies for division. I'm going to show you 2. I like to do division into fractions. So I'm going to show you first how to do division into fractions, and then I'm going to show you how to do long division into decimals. Again, I would way rather you work with fractions. It's more applicable going forward. We use fractions all the time. We don't very often use decimals, so I would like you to focus on the fractions and turning it that way. However, if you want to know decimals, you should have some sort of strategy for that as well. Let's start with this. 1.8 divided by 3. Instead of writing it that way, I'm going to write it this way. 1.8 divided by 3. So I'm going to write it as a fraction. It means the same thing, right? That's what a fraction is. It's division. And then I'm going to try to simplify this fraction. To do that in the past, what we've asked ourselves is like, what number divides into 3 and the same number divides into 1.8? But that's really hard. The reason it's really hard is because of this decimal. So what we're going to do is we're going to try to get rid of that decimal. And the way we're going to do that is by utilizing our equivalent fractions that we learned earlier in the year. What we're going to do is we're going to multiply the top and the bottom by 10. The reason I'm choosing 10 is because I know that multiplying by 10 takes the decimal and it moves it 1 spot to the right. That's what multiplying by 10 does. So my equivalent fraction will become 18 on the top, because the decimal is now to the right there, divided by 30. This is now a fraction that I can actually work with and manipulate. So now that I'm looking at 2 whole numbers, I can ask myself, what numbers divide into 18 and divide into 30? There's actually a few numbers that do. So if you look, I could divide both of those by 2. I could divide both of those by 3. I could divide both of those by 6. Usually when you're doing equivalent fractions, you want to divide by the biggest possible number. So we're going to divide both of these by 6. When I divide both of them by 6, 18 divided by 6 is 3. 30 divided by 6 is 5. This means that my answer of 1.8 divided by 3 is the same thing as saying 3 over 5. We also did a lot of work earlier in the year on fractions, and we know that 1/5, so 1 over 5, is 0.2. So if I have 3 over 5, that means I have 0.2 plus another 0.2 plus another 0.2 because I have 3/5. That means 3/5 equals 0.6. That was one of the things that you should have known from previous unit, changing fractions to decimals. Dividing by 5 is one of the ones that we knew. So that shows you how you can go from division into fractions and then into decimals. So you can have an answer either way. Again, as much as most of us don't like fractions, you're going to want to try to get comfortable with them. So 3 over 5 is probably the answer that I would most likely be looking for, but they are the same thing. So both answers are acceptable. It's just I know that in your future math lives, in Math 10, Math 20, Math 30, you're definitely going to need fractions. So you might as well start getting used to answering things in reduced fraction form. Awesome. Let's try K. So if I look at K, I have 2.4 divided by 6. If you were to ask me that right now, I'm very good at math. I could not tell you what 2.4 divided by 6 is. It's too hard. So what I do is I change 2.4 divided by 6 into a fraction like that. 2.4 over 6. And then I work on calculating that fraction and reducing it into the lowest terms fraction. I can't reduce that right now. The reason I can't reduce that right now is because this decimal, right? That decimal makes things hard. So the way that we get rid of decimals is by multiplying by 10, because that will move the decimal one spot to the right, which will give me actually a whole number that I can then work with. So I'm going to multiply the top and the bottom by 10. When I do that, it gives me 24 on the top. On the bottom, it gives me 60. Now that I have 24 divided by 60, I have a fraction I could actually reduce. The idea is that you always divide by the biggest possible number. So try to find a really big number that divides into both 24 and 60. Sometimes that's hard though, and there's obvious ones that stick out that are smaller numbers, and it is okay to do that. So 24 divided by 60, I'm going to divide both of these by 2, just because it sticks out to me that they both divide by 2. When I divide both by 2, I get 12 divided by 30. And I then check to see, hey, maybe I can reduce that fraction even more. So 12 divided by 30, it could divide by 2 again. This then gives me 6 on the top and 15 on the bottom. 6 and 15 can divide again. So both those numbers can divide by 3. And that gives me 2, I've run out of space, I apologize, 2 over 5. So you can divide multiple times to reduce a fraction down to its lowest terms if you can't find the really big number that works. 2 over 5, we know that 1 over 5 is 0.2. So if you have 2 over 5, that would be 0.4. Again, we did this type of conversion in previous units. I think it was unit 4 or 3 or 4 that we worked on those fractions. I just can't remember right now. So my answer is 2 over 5, which is the same thing as saying 0.4. Both of those answers are acceptable. Awesome. Last one. I'm going to go a little bit faster. So instead of saying division, I'm going to rewrite this as a fraction. I'm going to notice that the fraction has a decimal. I don't like that decimal, so I times the top and the bottom by 10, giving me 76 over 40. I then work on reducing that fraction. So I want to find a number that divides into both of those. I know both those divide by 4. If you divide by 2, that's fine. It's just you're going to have to divide by 2 again. On the top, 76 divided by 4 is 19. 10 divided by 4 is, or 40 divided by 4 is 10. This can't reduce anymore. So my final answer is 19 over 10. we remember that the way that it works to divide things by 10, you take 19, and because I'm dividing by 10, I now move it 1 to the left. So this would become 1.9. So if multiplying moves the decimal 1 to the right, dividing moves it 1 to the left. Again, we did 0.10 or divided by tens in that previous unit where we talk more in depth about that trick. So my answer is 19 over 10, or it's 1.9. Awesome. That's the end of multiplying, dividing, adding, subtracting with decimals.